Good afternoon. My name is Grant Foster. I'm going to be discussing Project 2, titled The Modeling of a Double Pipe Heat Exchanger. Double pipe heat exchangers transfer thermal energy between two concentric pipes. They're widely used in industry, and the purpose of modeling a heat exchanger system is because the heat transfer, although typically efficient, controlling the temperature of the fluid being heated at a specific set point can be challenging. Therefore, developing a mathematical model of the system is the first step in analyzing and eventually controlling the system. By modeling the system, an output response to various inputs can be predicted with close proximity and compared with experimental results or simulation, which you'll see later in the project. After the system is analyzed, the design process involves finding a system that accomplishes the desired task based on the particular parameters, and that involves the design and synthesis portion, which will not be included in this project. Applications of this type of system are widely used in laboratories as well as those laboratories for education. Widely used in oil and gas industry, heating and air conditioning, HVAC systems, as well as many other process industries such as food and chemical processes. Now, I became interested in this project when my senior design team chose to build a double pipe heat exchanger as our project. One of our tasks is to analyze the heat transfer rates of our system. This project will help to achieve that. Works that involve modeling heat exchangers have been done extensively in both education and industry. However, because we're using LabVIEW to control our system, that's one aspect of the design that I haven't seen in any of the other projects. Due to the complexity involved, a LabVIEW program will not be included in the scope of this project, but this is just for clarification on why I'm interested in what we're doing in our senior project. Now, the project outcomes of this project were first to set the design variables, the parameters, to assign some values to those and do some initial calculations in Excel for comparison and analyzing that against our simulation results. But first, the equations of motion were derived. The differential equations were derived, and therefore we got a state space representation from the differential equation. And then I developed continuous time and discrete time models. I represented that in MATLAB, as well as developed the plot of the impulse response. And finally, a CFD, computational fluid dynamics analysis, was done using both a maximum and minimum flow. And by doing this, we can compare this to the results as well as analyze our system in another fashion. Thank you for your time, and have a great day.